Hey everybody, welcome to Chapter 2 of Business Statistics. This one is about how we display descriptive statistics. It shouldn't be too horrible, so I will try to just walk you through the main points. That is, if I can get my clicker to click to the next screen. Let's see. There we go. All right, so there you can see the kind of map of how things are laid out for this chapter. We talked in the last chapter a little bit about the difference between quantitative and qualitative data, so there'll be a little bit of difference in how we display that information. And anyway, so let's just get to it. Stand by just a second. I'm having a little bit of a technical difficulty with my software here. I think I have it fixed. All right, good. All right, so the good news is that there's a lot of things built into Microsoft Excel, so it's good to get comfortable with them. So if right now you're saying, I'm not very comfortable with Excel, rather than saying that as an excuse, say it as like a mantra, like I'm going to get better with Excel, because we're going to use it a lot in this course. For some of the things, we'll even have to use the analysis tool pack, and when we get to that, I'll show you how to activate the analysis tool pack. Actually, I'll show you right now. So this is Excel 2013, but it works the same in the newer versions of Excel. You go to Options, go to Add-ins, then you go to Manage Excel Add-ins, and then you click on Analysis Tool Pack and hit OK, and now it's set up so that you can use it. Actually, they're showing you it's a little bit different in 2010 and in 2013, but it's pretty intuitive. I've been able to figure it out in both. All right, so when we're dealing with quantitative data, remember that there's two types, qualitative and quantitative. So first we'll talk about dealing with quantitative data. Remember, that's numbers that have a meaningful difference between them, as opposed to qualitative, which are just labels and things like that. All right, so one of the common ways that we will deal with quantitative data is what's called a frequency distribution. It just shows us how many observations we have of each type of data, and usually what we'll do is we'll separate our data into a specific interval or grouping of data. I'll show you an example. So over on the left, you can see a bunch of just raw data, right? The number of iPads sold in each of 50 days. So we can break that down into a frequency distribution on the right that shows the number sold per day, 0 through 5. And then the frequency, or each time that was observed. Okay, pretty easy. Remember that within our quantitative data, data can either be discrete or continuous. So discrete data are observations that can be counted are typically whole numbers, versus continuous data, which is measured information like weight and time and distance, etc. And it's usually not whole numbers, but a whole number plus with a decimal of some sort. So there's some examples of each. I won't read them to you because you're intelligent and I don't want to insult your intelligence. All right, so in addition to our frequency distribution, which just shows the number sold, in this case, right, it was iPads, we can do what's called a relative frequency distribution, which represents the number sold as a percentage of the whole. So for the data set we did before, we have the number sold per day, the frequency, or how many times we observed that number, and then the relative frequency. So for 0, it was observed 5 times out of a total of 50 of observations, so the relative frequency was 10%. The example there is 2. If they sold 2, they observed that 14 times out of 50, so the relative frequency was 28%. So that's a relative frequency distribution. And then they have something called a cumulative relative frequency distribution, where not only do we usually represent things as a percentage of the whole, but we also can represent them in a cumulative way. So if we look at it, let me just give you the example. You can see that 0 is 10, there were 5 out of 50, so that was 10%. And then 1, it has 8 out of 50, which is another 16%. So the cumulative relative frequency of 0 and 1 is 26%. Cumulative just means we add it up as we go. So here on the example, when we see 3, we would say that there were 13 observations of 3 sold, which is 26% of the total. And then the cumulative relative frequency of 3, 2, 1, and 0, or all days when we sold 3 or fewer, would be 80%. You can see how valuable that is when you start to say, hey, 80% of all days that we could be open, we sell 3 or fewer, which means we probably should estimate that on average we're going to, it's going to be somewhere between 0 and 3. So a histogram is really just a bar graph that shows the frequency distribution. So it looks something like this. You can see that they can be shaped in a number of ways. Symmetric, meaning the highest points in the middle, tapering off to either side. This looks like maybe the grades in a class, right? Still symmetric, but wider spread on the second one. Or not symmetric. That class had the highest grades were 70%, the highest number of people earning those grades, down to kind of slopes down to the right. All right, so the frequency distributions I showed you in the examples were pretty easy because they used a single number class, right? They had the days when we sold 0 iPads, days when we sold 1, 2, 3, 4, etc. But often what we have to do if we have a large number of classes is we have to combine classes into a range or a group. So here's some basic instructions, and I will read that top part to you. Ideally, the number of classes in a frequency distribution should be between 4 and 20. That is because if we get less than that, it doesn't tell us much by looking at the frequency distribution. And if we get more than 20, there's just too much information there. So what we do is we try to lump together, maybe we'll say 4 to 6 and 7 to 9, etc. And that allows us to limit the number of classes that we're going to use. So here's a method that they're going to have you use for the homework for determining the number of classes in a frequency distribution. Here's the rule. 2 to the k is greater than or equal to n. So we're going to find the lowest value of k that satisfies the rule. Okay? So if our n is the number of data points, so in our example we had 50. If we do 2 to the k equals n, when k equals 5, that's less than 50, so that doesn't satisfy the rule. But when k equals 6, that equals 64, and that is greater than 50. So the lowest value of k that satisfies the rule, in this case 6, that's the number of classes we should divide our information up into. Once we know the k, or the number of classes we're going to have, we can figure out the range of each by taking the maximum data value minus the minimum data value and dividing it by k. In real life, just know that class widths don't have to be super specific. This is just one method, and the method they're going to use for this textbook. So when you do your work, that's how they're going to expect you to figure out. But in real life, we kind of define the classes in a way that works best for the information we're using. So like they say, choose class boundaries. Here's some rules about them. They're easy to use, easy to read. 3 to 6, 6 to 9, 9 to 12 is better than these weird decimals. And then we can find the frequencies by recording the number of observations in each class. Right? So number of minutes, 0 to less than 3. We'll just count the number of times that the data is between 0 and less than 3, and so forth. So here's some basic rules. Again, I won't read them to you, but these are things to follow when you are setting up your classes. All right, so it's sometimes confusing and difficult to tell if you're dealing with discrete data or continuous data. So I would tell you that just remember that discrete data are represented as whole numbers, and continuous data are represented as whole numbers and decimals. It says some data are technically discrete, including age, income, etc., but are displayed in a continuous format. So anytime there's a wide range of values, we might consider displaying our discrete data as if it were continuous. That's what they're getting at here. All right, so here's some other ways that they will display this data. One is what's called a percentage polygon. This is a little confusing if you've never done it. But the height of each midpoint represents the relative frequency of the corresponding class, and we use to compare the shape of two or more distributions on one graph. So if you see this, now you can see this looks a lot like the histogram, but instead of it being a bar graph, there's just a point at the center of each point that would have been, right? It still has the cumulative percent, or the percentage of customers. Sorry, I'm looking at the percent polygon. Percentage of customers on the left and the number of minutes. And it lets you compare two different data sets. So they have the Denver data set and the Phoenix data set. Then on your right, you can see the cumulative percentage polygon. And that's similar, except instead of on the left of having, it doesn't have percent of customers, it has the cumulative percent of customers. So you can see it goes all the way up and stays rising from left to right. I promise you this is a little confusing as I try to explain it to you, but when you get into the work, it won't be too bad. Okay. So how do we display qualitative data? Well, it's a little harder because the numbers don't have the same meaningful difference between them. But you can still use frequency distributions, just like we learned about, and other things like bar charts. You can also use what's called a Pareto chart. I like Pareto charts. I think they're a really valuable tool. What they do is they use a bar chart together with a line. The bar chart shows the relative frequency, like a frequency distribution. And then the cumulative relative frequency is done on a line. So you can see, for example, this is return rates. I think return rates for QVC. We could see that defective products accounted for 51% of all the returns. And then people were disappointed accounted for about 20% of the returns. And that the two of them together, by following the line graph up, account for 75.6%. And then the no longer wanted accounts for, about 15%, something like that. And combined, those three, defective, disappointed, and no longer wanted, account for 91%. That's valuable to me as a decision maker because I can see that a relatively small number of issues are causing a big number of my problems, and that's valuable. Pie charts are another good way of sort of categorizing and looking at information. So you know what a pie chart is. This is population by continent. I won't spend much time here than say, you know this, and the Excel will make these for you. Contingency tables, another way, it just organizes the data into columns on a table. So here you can see 7-Eleven customers, they're having how they pay on the left-hand side and their gender. And that helps them to learn that more females than males pay with credit card. That may be valuable to us. And then there's a relative contingency table where you just take the contingency amounts, for example, 7 out of 20, divide that out and say that 35% of female customers, or 35% of customers are female and pay with credit card. There's a stem and leaf display. This is something you probably learned in 6th grade and then forgot. And so it just takes the data set and then lets you, I guess, display it in a way that is a little bit more concise. So what you do is you put the tens digit on the left-hand side of the bar and then the ones digit on the right-hand side of the bar. And so that gives you a summary at the end of all the data. So we know we would have 78 twice, 79 3 times, 80 4 times, 81 2 times, 82 1 time, etc. It just sort of, I guess, gathers the information and lists it by tens. You can also have a more detailed stem and leaf display that does by fives. Scatter plots, they just sort of take the data and provide a picture of it where things are plotted on the x-axis and the y-axis, so it compares 2 points of data. Again, this is probably not something new to you. You've seen this lots of times. Really what a scatter plot does is it compares changes on an x variable and how they affect changes on the y variable or y-axis. In a line chart, same thing, nothing new here. Excel will make these for you. It just plots x and y and then draws a line in between them. There's an example of how you can use Excel to do it. And that's really it. So I feel like I kind of rushed through this, but that's because a lot of this is common sense, and actually the more I try to explain it, the more confusing it becomes. So it's actually better for you, I think, if I just kind of move through it and then let you get on with the work. Of course, if you have any questions, you can always call me or email me, and I will do my best to answer. Good luck with the chapter, and have a great day.